Hi, my name is Saptak Sen. I'm a product manager in the SQL Server product management group. Today I'm going to talk about big data, specifically with BI and SQL Server and Apache Hadoop. I love this slide because it has a wonderful quote that I chanced to read a month back while I was reading a book called The Information, A History, A Theory of Flood by James Click. And this quote is by John Archibald Wheeler, who is a very famous physicist who worked very closely with Albert Einstein on his theory of everything during Albert Einstein's last 15 years. It says what we call the past is built on bits. Now it's a profound statement because when you think about it, if the past is built on bits, you have to be able to process those bits to kind of predict the future. And that's a lot of bits we are talking about. So IDC predicted that actually it's not a prediction. Last year in 2010, there was 1.2 zettabytes of new information that was created. 1 zettabyte is 10 to the power 21. That's a lot of data that got created. Even within Microsoft at Bing, we ingest about 7 petabytes of data every month. Twitter creates more than 1 terabytes of data. Cisco predicts that by 2013, the annual internet traffic is going to reach about 667 exabytes. These are all very big numbers. Now, it's not just about the size of data. There are other aspects of it. So let's look at some of them. So traditionally, if I had an e-commerce site 10 years back at the height of .com, I would I would have some kind of a database behind my website to capture the user data, the new purchases that's happening, the new SKUs of products that I'm introducing, and so on. If you think about it, all this data was being entered by somebody. It was being keyed in by somebody. And then I could build cubes, dimensions, and basically I would put it in an enterprise data warehousing infrastructure, and it would work well for me. But as kind of more and more computation came in, I would like this e-commerce sites wanted to optimize their sites with user behavior, and they started capturing the log data. One kind of log data is called clickstream. So as we go, say, on Amazon.com and try to shop, it's probably recording our every click, which items we look at, and before deciding our final purchase. Now, this generates a tremendous amount of data. Again, traditionally, we would kind of use some kind of a ETL process to glean some of the information out of that, all that data, and stick it back into the data warehouse. But most of the data, we actually threw it out. We never captured those data. Now, that has slightly changed. With the storage costs plummeting, we can now afford to keep all that data around. And not only that, we actually now have infrastructure to use that data to answer questions that we never could before. So just to sum it up, again, it's not just about a lot of data. It's also about new data sources, very non-traditional data types, and also we have new technologies to harness all this data, and we have new economical pressure to make, which forces us to make more insights out of this data. Now let's look at how it all works. One of the common bottlenecks when we have lots of data is that our disk bandwidth, or how fast we can access the data on the disk, hasn't gone up or hasn't kept pace. So one way to get around that bottleneck is to divvy that that huge amount of data into smaller pieces and distribute across many physical hard drives. Now, once we do that, we can have all these different disk drives process this data parallelly, and thereby we can reduce the clock time, wall clock time to process this data. Not only that, it gives us the added advantage of being able to grow our infrastructure as we have more and more data. Now, I told you that one of the key bottlenecks is the disk bandwidth, or how fast we can read the data on the disk. The second biggest bottleneck is the network speed. So we definitely don't want to move the data around unless we absolutely need it. So one of the common approaches is to instead move the code around and try to keep the data in where it is as much as possible. This whole thing is called data locality. The better data locality you have, the faster you can process or more data you can process. Now, let's look at the architecture, a common architecture that we use to address this kind of requirements. Hadoop is infrastructure which has two different parts. The part that you see bottom of the red dotted line is the storage layer, or often called as the HDFS layer. HDFS stands for Hadoop Distributed File System, and it has two main components, the name node and the data nodes. Now, the data nodes obviously store the actual data or pieces of the actual data, and the name node contains the metadata which says which piece of data is where essentially. And then above the red dotted line is the computational infrastructure. Again, it has two main parts, the job tracker and the task tracker. The job tracker decides what piece of code will run where after or interacting with the name node to figure out what piece of data is where. And the task tracker is responsible to actually run the code. Now, let's compare and contrast between traditional RDBMS and MapReduce type of computing. Now, one of the key requirements we discussed about is almost unlimited scalability, and MapReduce caters to that. And the second aspect of it is that we need to be able to process that data. Now, how we process that data is slightly different than with traditional RDBMS. In traditional RDBMS, we can build indexes, we can build dimensions, and so on. Now, all these architectural pieces actually help us to provide more interactivity with the data, so that we can interact with the data faster. So if we are asking or issuing a query, the results come back really fast because we have indexes and dimensions and so on. In case of a MapReduce kind of infrastructure, it's mostly a batch system. So it lets you process a lot more data, but there is it is a batch process. So it takes some time to get the results back, depending on the complexity of the processing as well as how much data you are trying to process. The third part is what's the update pattern? In case of traditional RDBMS, you can read as well as write as many times as you want. But in typical MapReduce kind of framework, write is highly discouraged. The access pattern that it's most optimized is write once and read many times. The next part is the schema. Often MapReduce kind of framework is known to be able to process unstructured data. Now, every data has some structure or the other. The reason we call it unstructured data is because we haven't yet applied a structure to it. So, MapReduce kind of a framework allows us to store the data without specifying a structure. That is what it means. During query time or when we are actually processing, we do have to apply a structure. So, it also lets you apply many different types of structure or schema based on the kind of processing you want to do on that data. So, that provides a lot more flexibility than traditional RDBMS, where you have to decide what kind of schema you want to apply while you are storing the data. Obviously, as a result of this, the integrity and consistency of the data is much lower than the traditional RDBMS. That is the trade-off here. And in terms of scaling, though, MapReduce can easily scale. It's kind of linearly scalable for most algorithms. So, you can add more and more systems, and it should be able to scale to more and more data, as well as the wall clock time should come down significantly. In case of a traditional RDBMS, because of the of its architecture, we can process terabytes of data, but it has limits on how much it can scale to. Now, in any kind of data analytics, it's not just about storing the data and then running an algorithm on that data. It's much more than that. I mean, there are aspects of it, or phases, which spans across data acquisition and modeling, collaboration and visualization, analysis and data mining, and finally sharing and preservation. And these are all iterative process. Currently, the solutions that are out in the market are often provide very disjoint experiences, and for each different data type, you have these different tools which don't talk to each other, and so it's not very conducive for data aggregation, mashup, and those kind of processing. So, one of our key goals was to make sure our core infrastructure that we offer spans through all these different phases. One of the examples of that is the tools for data visualization and exploration. Through Excel, Power Pivot, Power View, and SharePoint, we provide the whole gamut of tools which lets you easily visualize your data, interact with your data, as well as have workflows around those data, and securely manage your data. So, all these are built-in capabilities of the platform which work extremely well together across all the phases of your data analytics. Now, here is a snapshot of our self-service BI tool, which is Power View, which is hosted on SharePoint. So, you don't need to really install an end user application, and it also provides a great way to be able to collaborate with other users in your organization as well as your business partners. So, in some of the other phases, what we saw is, as we have more and more data, the quality of the data, the consistency of the data, the ability to make sure we don't have duplication of the data becomes all the more important. So, downstream from where we just kind of process huge amount of data, it becomes very important to be able to manage the data quality and as well as the consistency of the data. So, with SQL Server 2012, the data quality service and master data service actually helps you provide that. And of course, our parallel data warehousing infrastructure lets you very easily process up to 600 terabytes of data. And not only that, it's very extremely easy to use. It's very stable, well supported, performant, and without the headache of you having to cobble together your own solution. So this is this provides a lot of value when you want a SMP data processing infrastructure with very high return on investment. Security has been one of the areas which we have been very focused for over last 10 years, and the results of that actually show. SQL Server has the lowest vulnerabilities among all the other databases out there, and we are committed to making sure that all new products within Microsoft is extremely secure, and not only that, has the right security features both for the enterprises as well as the small and medium businesses to be able to secure and manage their data. Now, coming back to some of the announcements we did recently, last pass in early November, we announced that we will have Hadoop-based distributions for Windows as well as Azure. We have already delivered on the first part of that promise. We have a CTP, or Community Technology Preview, of Hadoop on Azure already available, where the customers are trying it out. We also have a strategic partnership with Hortonworks, where we are collaborating with them to provide the best platform possible. In addition to that, we want to make sure that this platform, data platform, is available to as many as broadly as possible. So as part of that, we have announced we will provide a JavaScript-based framework for data processing, for parallel data processing. We plan to actually make it open source. So we have contacted Apache Foundation to make it Apache project, so that we can contribute this back to the community. We also released Hadoop connectors to SQL Server and Hadoop connectors to Parallel Data Warehouse. This lets you move data from SQL Server to Hadoop and vice versa, and from Parallel Data Warehouse to Hadoop and vice versa. We also announced that we will provide ODBC drivers for third-party applications to be able to integrate with Hadoop on Windows and Windows Azure, as well as a Hive add-in for Excel to be able to interact with your data on Hadoop from Excel. We are also will also provide deep integration with Power Pivot and Power View. Now, in this picture, if we start from the bottom of it, what we are trying to say is that irrespective of where the data comes from, whether it's coming from sensors, devices, bots, crawlers, or other line of business applications, you have the whole stack, Microsoft stack, to be able to gain insight from that data. Whether you want to store that data on Hadoop on Windows or Windows Azure, or you want to store it on the enterprise data warehousing platform, it doesn't matter. You can harness the power of the Microsoft BI platform like SQL Server Analysis Service and SQL Server Reporting Service to process that data. Not only that, you can use the tools like Power View, Power Pivot with Excel, and the other predictive analytics tool to be able to visualize and interact with that data. So as I discussed in a few slides back about our JavaScript framework for processing a lot of data on Hadoop, this frameworks is geared towards the millions of JavaScript programmer out there. Now they can write Hadoop jobs at a much higher abstraction layer without having to worry about low-level plumbing. We also, as I discussed before, that we just released the community technology preview of Hadoop as a service on Azure. This is a screenshot of that. As you can see, we have provided a very intuitive interface to create your jobs, to monitor your jobs, to manage the data on Azure, and essentially even run interactive commands on top of the data that's stored on Azure. So our goal is to ensure that this whole framework is as easy to use as possible. Again, to sum it up, we want to make sure that we provide the broadest access to this exciting data processing infrastructure. We want to make sure that Hadoop on Windows and Windows Azure provides enterprise-grade experience through integration with Active Directory, System Center, as well as being very easy to configure and manage on Windows as well as Windows Azure. And we want to accelerate the time to insight through deep integration with the popular Microsoft Business Intelligence platform. To learn more, please visit the Microsoft Virtual Academy. We'll provide webcasts, hands-on labs, and documents so that you can learn more about this. Please download SQL Server 2012 and play with it. Tell us what you think. I think you'll love it. Also, make sure you sign up for the Hadoop on Azure community technology preview and play with it. And please participate in our other virtual launch activities to collect points for winning prizes. Thank you so much.